heat does not arrive like weather. It arrives like pressure, heavy and unrelenting, pressing down until even the air feels solid. At 120 degrees, streets shimmer as if liquefying, metal railings burn the skin, and shadows offer no relief. Inside modern homes, glass walls act like lenses, pulling the sun inward, concentrating it. Drywall warms quickly, thin insulation surrenders, and machines are forced into a constant, desperate battle against physics. Air conditioners roar without pause, compressors straining, coils overheating, until one by one they fail. The sound stops. Power grids sag. Silence replaces airflow. Rooms designed around uninterrupted electricity become sealed containers of heat, and people who fled indoors for safety realize they have stepped into a trap. Now hold that same heat against a room built 8 centuries ago. The outside air is just as brutal, just as merciless. But inside, something feels wrong in a way that almost defies expectation. Thick stone walls rise around you, cool to the touch even as the sun beats down. Light enters reluctantly through narrow openings, stretched thin by depth and shadow. The air barely moves, yet it does not suffocate. The floor remains cool beneath bare feet. The walls do not react quickly. They do not surge with temperature. They absorb. They delay. They hold. The room does not panic. It waits. This is not nostalgia, and it is not luck. It is the result of engineering choices made by people who assumed failure as a starting point rather than an exception. If this kind of forgotten knowledge matters to you, make sure you're subscribed. We dig up what modern systems buried. The difference between these two spaces is not technological progress versus ignorance. It is a clash of assumptions. Medieval builders worked in a world where energy was scarce, labor was expensive, and survival depended on structures that could function without constant input. They built for interruption, for drought, for siege, for seasons that could not be controlled. Heat was not something to be erased with force. It was something to be slowed, redirected, and endured. Stone, mass, and geometry became tools for managing time rather than overpowering temperature. Modern buildings are born from the opposite belief. They assume energy will always arrive on demand, that machines will always compensate, that failure is rare and brief. Walls are made thinner to save cost and space. Windows grow larger to invite light, regardless of the thermal price. Interiors are sealed to maximize efficiency, trusting that airflow will always be provided artificially. Under normal conditions, this system feels invisible. Comfort appears effortless, but under extreme heat, the illusion collapses. Without electricity, there is no second layer of defense. Heat rushes in unopposed, and the very features that once signaled progress become liabilities. What medieval stone rooms reveal is not a romantic past, but a brutally honest relationship with physics. Heat moves at predictable rates. Materials respond according to their mass and density. The human body has limits that cannot be negotiated. Medieval architecture aligned itself with these truths. It used thickness to slow heat, darkness to limit energy, and inertia to create stability. Modern systems try to outrun these realities, and in doing so, they make themselves fragile. Standing in that stone room, with the outside world shimmering in unbearable heat, the realization settles in quietly. Comfort here is not absolute, but it is reliable. It does not spike or collapse. It holds steady because it was never dependent on constant power or perfect conditions. The room survives because it was designed with failure in mind. And that raises an unsettling question. If stone walls could hold back 120 degrees without wires or machines, what exactly did modern cooling systems gain, and what did they quietly give up? The answer begins not with technology, but with the weight of the walls themselves. At extreme temperatures, speed becomes the enemy, even though modern design treats speed as a virtue. Thin walls heat quickly. Lightweight materials respond instantly. Sunlight strikes a modern facade, and within minutes that energy has passed straight through, raising indoor temperatures almost in real time. The building feels alive in the worst possible way, reacting to every shift in the sun with no resistance, no delay, Comfort becomes a race against physics, and machines are expected to run faster than heat itself. Medieval stone rooms were built on a completely different understanding. Their walls were not measured in inches, but in feet. Tons of stone stood between the sun and the interior, not to block heat entirely, but to slow it down. When solar energy struck those walls, it did not surge inward. It seeped, spreading gradually through dense material, dispersing over time. By the time warmth reached the inner surface, the day was already turning. Evening winds began to cool the exterior, and the process reversed. The heat that entered during daylight was released slowly into a night air that could absorb it safely. Inside, temperature changed so gradually that the human body barely noticed. This principle is known today as thermal mass, but medieval builders practiced it long before equations gave it a name. Stone does not resist heat by fighting it. It resists heat by delaying it. Energy moves through mass at a finite rate, and thickness stretches that journey across hours or days. In climates where days scorch and nights cool, this delay is everything. It transforms violent temperature swings into gentle waves. The building becomes a buffer, absorbing extremes so the interior can remain stable. Modern construction largely abandons this logic. Concrete and stone are replaced with lighter composites, designed for speed of assembly and a lower upfront cost. Walls are engineered to insulate rather than store, which works only as long as the temperature difference is modest and constant energy is available. Under extreme heat, insulation slows heat slightly, but offers no capacity to absorb it. Once saturated, it passes energy inward relentlessly. Air conditioners are then forced to remove heat as fast as it arrives, hour after hour, without relief. The medieval room never asked its occupants to win that race. It changed the race itself. Heat arriving at noon was not felt until long after the sun had moved on. The building worked on a different clock than the environment outside. That difference created safety. It also shaped daily life. People slept during the hottest hours, resting against cool stone floors where dense material had stored the night's chill. Activity returned in the evening, when walls gently released warmth instead of trapping it. Thickness was not wasteful, it was insurance against the sun. This was not a misunderstanding of comfort, it was an acceptance of human limits. Medieval societies knew that bodies overheat faster than buildings fail. By slowing heat transfer, they protected people first, and adjusted behaviour second. The science behind it is straightforward. The consequences are profound. A structure with sufficient mass can coast through power outages, heat spikes, and environmental stress without catastrophic failure. One without mass has no inertia. It rises and falls instantly, leaving its occupants exposed the moment systems falter. Standing inside a stone room during extreme heat, the absence of urgency is striking. There is no rush of temperature, no sudden spike that demands immediate response. The walls feel patient. They absorb the day quietly, without drama. Modern interiors rarely offer that experience. They fluctuate rapidly, swinging from overcooled to unbearable, depending on the state of machines outside the room. Yet even thermal mass has limits. Heavy walls can slow heat, but they cannot solve everything alone. Without careful control of sunlight, mass simply becomes a storage problem waiting to be overwhelmed. Medieval builders understood this too, and they paired weight with another, equally deliberate choice. They learned to ration light itself. Modern buildings invite the sun inside as if it were harmless, then spend enormous energy trying to push it back out again. Glass walls promise openness and brightness, selling light as comfort, productivity, and status. But at 120 degrees, sunlight is no longer illumination. It is fuel. It pours through windows, strikes floors and furniture, and converts instantly into heat that has nowhere to go. Machines hum in response, fighting an enemy that has already crossed the threshold. Medieval builders treated sunlight with far more suspicion. They understood, intuitively and through lived experience, that light carries energy, and energy becomes heat the moment it touches matter. Their response was not curtains or coatings or mechanical shading, but geometry itself. Windows were narrow, deeply recessed, and carefully positioned. Walls were thick enough that openings became tunnels rather than frames. Light entered reluctantly, stretched thin by shadow, diffused long before it could strike interior surfaces directly. Rooms remained dim, not because medieval people disliked brightness, but because brightness had consequences. Darkness was not deprivation, darkness was protection. At extreme temperatures, this restraint mattered more than any machine ever could. Stone does not amplify sunlight the way glass does. It absorbs and scatters it, reducing intensity before heat can accumulate. By limiting direct solar gain, medieval rooms cut off the largest single source of indoor heating before it could begin. Interiors stayed cool, not through constant intervention, but through refusal. Excess light was simply never invited in. This design choice also aligned with human biology in ways modern spaces often ignore. In dimmer environments, the body naturally slows. Eyes adjust, movements become deliberate, metabolism drops slightly. During the hottest hours of the day, medieval interiors encouraged stillness rather than stimulation. Modern buildings do the opposite. Bright lighting, reflective surfaces, and expansive glazing push activity precisely when the body is under maximum thermal stress. The result is more movement, more internal heat production, and greater dependence on artificial cooling layered on top of already extreme conditions. Engineering follows belief. Medieval life assumed adaptation. Survival depended on working with the environment rather than overpowering it. Architecture reflected that humility. Rooms were designed to cooperate with the sun's path, not challenge it. Modern life assumes domination. Sunlight is welcomed indiscriminately, and systems are installed afterward to correct the consequences. When energy is abundant, this arrangement appears elegant. When energy falters, it becomes dangerous. The medieval stone room did not require blinds, tinting, reflective films, or automated shading systems. It did not need updates or maintenance schedules. Its darkness was structural, permanent, and reliable. It worked during blackouts, droughts, and heat waves because it was never dependent on active control. Shade was built into the wall itself, but darkness alone is not enough. A sealed, shaded room can still become lethal if air stagnates. Heat may be slowed, light may be rationed, yet without movement, warmth and breath accumulate. Medieval builders recognized this risk just as clearly as they recognized the danger of sunlight. Their final solution was subtle, invisible, and relentless. They taught stone rooms how to breathe. Heat becomes deadly fastest when air stops moving. At 120 degrees, stillness turns suffocating, trapping warmth against the skin and preventing the body from shedding it. Modern buildings respond to this threat with force. Fans spin, ducts push, motors drive air through sealed spaces that cannot breathe on their own. The moment power fails, that motion collapses. Air becomes trapped, heat pools, carbon dioxide rises, panic follows. The space itself offers no help. Medieval rooms were designed with a quieter assumption. Air would always need to move, and force could never be guaranteed. Instead of pushing air, builders learned to invite it. They shaped rooms around pressure, temperature, and gravity, letting physics do the work continuously and without effort. Warm air rises, cooler air sinks. This simple truth became the foundation of passive ventilation systems, refined over centuries of trial and survival. High openings near ceilings or towers allowed hot air to escape naturally as it expanded. Low openings, shaded and protected, drew in cooler air from courtyards or narrow streets where stone and earth had absorbed the night chill. Thick walls acted as guides, smoothing airflow and preventing sudden gusts. The result was movement so gentle it was often unnoticed, yet constant enough to prevent stagnation. The room breathed the way lungs do, slowly, rhythmically, without conscious effort. Courtyards played a crucial role in this system. Sunlight heated their upper walls while shaded ground remained cool. As warm air rose and exited upward, cooler air was pulled across the courtyard floor and into surrounding rooms. Towers and vertical shafts acted as chimneys, amplifying this effect by increasing height and pressure difference. Even slight temperature variations were enough to sustain circulation. No fans were required, no switches needed to be flipped. The system worked because it never stopped working. Modern buildings often reject this logic entirely. They are sealed tightly for efficiency, relying on mechanical systems to manage air quality and temperature. Under normal conditions, this produces control. Under extreme heat or power failure, it produces danger. Without fans, sealed rooms trap heat and exhaled air alike. Stress rises as oxygen levels drop and perceived temperature climbs. Medieval rooms never assumed continuity of force. They assumed interruption was inevitable. Ventilation paths were carved into the building itself so that air movement could not be turned off. The science behind this is straightforward. Pressure gradients move air from high to low. Temperature differences create density changes that drive circulation. Medieval builders may not have described these processes mathematically, but they understood them viscerally. Structures that failed to breathe were abandoned or modified. Structures that kept people alive were copied. Over generations, this feedback refined designs into systems that could function under extreme conditions with remarkable reliability. Even at 120 degrees, gentle airflow reduces perceived heat dramatically. Evaporation increases, skin cools more effectively, breathing becomes easier, the body regains a measure of control. Medieval ventilation did not eliminate heat, but it prevented heat from becoming overwhelming. That distinction meant survival. These systems also scaled efficiently. One courtyard could cool multiple rooms. One tower could ventilate an entire complex. Cooling was not individualized and mechanical. It was communal and architectural. Energy was conserved by design rather than demanded by machines. Standing in such a room, the absence of noise is striking. No hum of motors, no rush of air, just a slow exchange that never announces itself, yet never stops. Modern spaces rarely offer this experience. When machines fall silent, so does the air. Medieval spaces continue, indifferent to outages or failures, but architecture alone was never the full solution. Even the best designed rooms required people to live differently within them. The final layer of medieval cooling was not built from stone or carved into walls. It was embedded in daily behavior, habits shaped by heat and refined by consequence. Modern life treats heat as an error, something to be corrected instantly so routines never have to change. Medieval life treated heat as a condition, something to be acknowledged and lived with because it could not be commanded away. That difference shaped not just buildings but bodies, habits, and time itself. When temperatures climbed toward unbearable levels, medieval societies did not demand the day continue unchanged. They retreated, they slowed, they adapted because the cost of pretending otherwise was immediate and physical. In the hottest hours, thick stone rooms became refuges rather than workplaces. Activity shifted to dawn and evening when air cooled and walls released stored heat gently instead of trapping it. Midday was reserved for stillness. People rested close to the floor where cooler air settled, understanding intuitively that heat stratifies and that height matters. Furniture remained minimal, not for style but to allow air to circulate freely around the body. Clothing was loose and breathable, designed to shade skin while allowing evaporation. Diets were lighter, reducing metabolic heat production when the environment was already hostile. This was not comfort in the modern sense, it was survival intelligence. Medieval societies assumed the human body had limits that architecture and behavior had to respect. Stone rooms stayed cool, not just because of their walls, but because people knew how to inhabit them. Stillness was not laziness, it was strategy. Silence was not emptiness, it was conservation. Modern systems promise uninterrupted comfort and demand uninterrupted output in return. Work continues at noon as if the sun were irrelevant. Artificial light keeps interiors bright. Screens glow. Machines compensate, pushing cooled air into spaces where bodies are still generating heat through constant motion and mental strain. The system holds until it cannot. When it fails, people are left without the behavioral knowledge to respond. There is no instinctive retreat, no practiced rhythm of adaptation. Panic replaces habit. Medieval cooling strategies were refined by ruthless feedback. Those who ignored heat paid with illness or death. Those who adapted survived. Over generations, this pressure shaped customs as surely as it shaped stone walls. What worked endured. What failed disappeared. The result was a culture aligned tightly with environmental reality, rather than insulated from it. Modern culture rarely experiences this corrective loop. Technology buffers consequences until failure becomes catastrophic instead of gradual. Air conditioning masks discomfort so thoroughly that warning signs are ignored. When systems collapse under extreme heat, there is no muscle memory for restraint or adjustment. Bodies are pushed beyond limits they have not been trained to respect. This is why medieval approaches appear primitive only at a glance. In truth, they were calibrated precisely to human physiology. Heat was treated as a force that demanded humility. Architecture slowed it. Behavior accommodated it. Together, they created resilience that did not depend on constant energy input. The stone room did not promise perfect comfort. It promised survivable stability. That promise held even when conditions became brutal. Modern systems promise control without compromise, and that promise breaks the moment stress exceeds capacity. This contrast exposes a deeper weakness in contemporary cooling. The problem is not only how buildings are designed, but how entire systems are expected to perform under pressure. And that flaw becomes impossible to ignore when we examine what air conditioning actually does, and why it so often destroys itself when it is needed most. Modern cooling feels powerful because it is loud, visible and immediate. Cold air pours from vents. Thermostats respond instantly. Comfort seems to obey commands. But beneath that responsiveness lies a fragile exchange that becomes most dangerous precisely when heat is at its worst. Air conditioning does not destroy heat. It moves it, concentrates it, and demands enormous energy to keep doing so without pause. At 120 degrees, that demand becomes relentless. Compressors run continuously. Electrical loads spike in unison across entire cities. Power plants strain. Transmission lines sag. The system heats itself while trying to cool the people inside it. This is the hidden paradox of modern cooling. The hotter it gets, the harder the system must work, and the more heat it generates in the process. Every air conditioner dumps waste heat outdoors, raising ambient temperatures further, forcing neighbouring units to work even harder. This feedback loop compounds stress on grids already stretched thin. Failure does not arrive gently, it cascades. One station trips, another follows. Suddenly, millions of interiors lose their only defence at the exact moment they need it most. Architecture amplifies this fragility. Thin walls allow heat to flood inward instantly. Expansive glass invites solar gain without restraint. Sealed envelopes trap warmth and exhaled air alike. Internal heat from appliances, lighting, and constant activity adds to the burden. These buildings are not designed to coast through failure. They are designed to function only when everything else works perfectly. When electricity falters, temperature rises rapidly. At extreme heat, minutes matter. Heat stress accelerates. Breathing becomes laboured. Decision-making degrades. What felt like comfort hours earlier becomes danger with terrifying speed. This is not a failure of engineering skill. It is a failure of philosophy. Modern systems are built on the assumption of reliability rather than resilience. They assume continuity of power, continuity of maintenance, continuity of infrastructure far beyond the building itself. Medieval systems assumed the opposite. They treated interruption as normal. Walls were thick because supply chains were fragile. Ventilation was passive because force could not be guaranteed. Cooling was embedded into structure because nothing external could be trusted indefinitely. Engineering disciplines understand redundancy when failure is costly. Aircraft, ships, and medical systems are layered with backups because lives depend on them. Medieval builders applied that same logic to buildings. The structure itself was the backup system. If food ran out, stone still stood. If labour stopped, walls still slowed heat. If movement ceased, air still circulated. Modern design externalizes responsibility. Cooling is outsourced to grids, plants, and networks far removed from the people who depend on them. When distance breaks, comfort breaks with it. The irony grows sharper the more closely it is examined. The more advanced the cooling technology, the more brittle the outcome under stress. Sophisticated systems offer extraordinary control under ideal conditions, but almost none under failure. Stone rooms offered modest comfort, but extraordinary reliability. They did not ask permission from infrastructure. They answered directly to physics, to mass, gravity, and time. Standing inside a modern building during a blackout, the contrast becomes visceral. The silence of dead machines feels unnatural. Air thickens. Heat presses inward without resistance. The building offers no help. In a medieval stone room, silence was normal. The building was never waiting for machines to intervene. It was already doing the work itself. This realization forces an uncomfortable question, one that grows more urgent as heat waves intensify and grids become less stable. What would it mean to design buildings as if failure were expected rather than unthinkable? What would it mean to value systems that degrade slowly instead of collapsing suddenly? The answer does not require abandoning technology. It requires remembering principles that once kept people alive without it. And those principles are not lost to history. They are waiting, embedded in stone, ready to be used again if we choose to look backward with clear eyes. The medieval stone room is often mistaken for a relic, something to admire briefly before returning to the comforts of the present. But standing inside it during extreme heat tells a different story. It does not feel obsolete, it feels prepared. While modern interiors strain and fail, this space remains steady, quietly holding its ground against forces it was designed to expect. The lesson it offers is not about nostalgia, it is about limits, and about what happens when design accepts them instead of pretending they do not exist. For centuries, comfort was never defined as perfect control. It was defined as survivability. Medieval builders understood that the environment would always win eventually, so they focused on slowing its advance. Thermal mass absorbed extremes instead of amplifying them. Shade was permanent, not adjustable. Air moved without permission. Behavior adapted instead of resisting. None of these choices were accidental. They were responses to a world where energy was precious, failure was common, and consequences were immediate. What makes this knowledge unsettling today is how easily it could be applied again. Modern materials can deliver thermal mass without medieval labor. Concrete, rammed earth, masonry, and hybrid systems can store heat just as stone once did. Deep overhangs and recessed windows can limit solar gain without sacrificing light entirely. Courtyards can still cool air. Passive ventilation paths can still move it. These principles are not mysterious. They are well understood, measured, and proven across climates and centuries. Yet modern design often treats them as optional, even inconvenient. Thicker walls reduce rentable space. Smaller windows challenge aesthetic trends. Designing for airflow requires patience and restraint instead of brute force solutions. Speed and spectacle win. Immediate comfort sells. The cost is simply deferred, hidden inside power plants, grids, and future crises. When those systems falter, the bill comes due all at once. As heat waves intensify and electrical infrastructure grows more strained, the medieval approach begins to look less like history and more like insurance, not because it promises luxury, but because it promises continuity. A stone room does not collapse into danger when systems fail. It degrades slowly, predictably, giving occupants time to adapt. That difference can mean the margin between discomfort and catastrophe. The most uncomfortable truth is that the knowledge was never truly lost. It was sidelined by abundance. When energy became cheap and reliable, architecture stopped needing to think about failure. When machines could overpower heat instantly, there was no incentive to slow it patiently. The discipline that once shaped walls, windows, and daily rhythms faded because it no longer seemed necessary. Now that assumption is being tested. Rising temperatures push cooling systems to their limits. Blackouts last longer. Urban heat islands intensify the very problem machines are meant to solve. Under these conditions, the medieval stone room stops looking primitive. It looks honest. It does not promise control without cost. It offers balance instead. Remembering this does not require abandoning modern technology. It requires redefining its role. Machines can supplement architecture rather than replace it. Cooling can become layered instead of singular. Buildings can be designed to survive without power first, and be optimized with power second. This shift does not reject progress, it grounds it. Stone rooms stayed cool at 120 degrees because they respected energy, time, and the human body. Modern systems fail because they promise control without consequence. Between those two philosophies lies a choice that is becoming harder to avoid. The final question is not whether medieval builders were smarter, it is whether we are willing to relearn what they already knew before extreme heat turns that lesson from history into emergency. The future does not announce itself with novelty. It arrives by repeating old pressures in new ways. Extreme heat is one of those pressures, ancient in its force, modern only in how unprepared we have allowed ourselves to become. When temperatures climb past survivable thresholds and machines begin to fail in sequence, what feels new is not the danger itself, but our shock at its return. Stone rooms were never designed for a medieval world alone. They were designed for reality, for a planet that does not negotiate with ambition or convenience. Inside those rooms, time behaves differently. Heat arrives slowly, air moves without demand. Darkness rests on the walls like insulation for the mind as much as the body. There is no illusion of mastery here, only an understanding of balance. These spaces do not promise comfort on command. They promise continuity, and in moments of stress, continuity matters more than luxury ever could. Modern cooling systems taught us to expect instant relief and constant control. That expectation reshaped cities, work schedules, and architecture itself. Glass towers rose in climates that stone once dominated. Walls thinned, windows widened. Entire populations came to rely on a single layer of defense against heat, trusting that power would always flow and machines would always respond. For decades, that trust seemed justified. Now, it is being tested more frequently and more severely. Each blackout during a heat wave reveals the same pattern. Interiors become uninhabitable within hours. Vulnerable populations suffer first. Emergency responses scramble to compensate for buildings that offer no passive protection. What appears to be a failure of infrastructure is, at its core, a failure of design memory. We forgot how to build spaces that could endure without constant assistance. We forgot how to live inside them. The medieval stone room stands as quiet evidence that another approach is possible. It does not reject progress, it reframes it. Technology becomes a supplement rather than a crutch. Machines enhance comfort instead of being solely responsible for survival. Architecture regains its role as the first line of defense rather than the last. In this framework, power outages are disruptions, not disasters. Heat waves are endured, not fought blindly. Remembering does not mean rebuilding the past brick by brick. It means restoring principles that modern systems abandoned when energy became cheap. Thermal mass slows extremes. Shade limits energy before it enters. Airflow must never depend entirely on force. Behavior matters as much as hardware. These ideas scale from individual homes to entire cities. They are not theoretical. They are already proven by centuries of human survival in harsher conditions than most modern populations have ever faced. As climate patterns shift and extremes intensify, the cost of forgetting rises. Cities that double down on glass and mechanical dependence will demand ever greater energy to remain habitable. Those that integrate passive strategies will bend rather than break. The difference will not be aesthetic. It will be measured in health, stability, and lives protected when systems falter. The stone room does not compete with the modern world. It critiques it. It asks a question that grows louder with every heatwave and every blackout. What happens when control disappears? What remains when machines fall silent? The answer is written into walls that have stood for centuries, holding steady while empires rose and collapsed around them. In the end, this is not a story about medieval builders being wiser than we are. It is a story about priorities. They built for endurance because endurance was non-negotiable. We built for convenience because it seemed safe to do so. The environment is reminding us that safety built on assumptions is temporary. Remembering in time means choosing to design for reality again. It means allowing buildings to shoulder some of the burden we placed entirely on machines. It means accepting that comfort without resilience is a fragile promise. Stone rooms stayed cool at 120 degrees, not because the past was superior, but because it was honest. The question that remains is whether we are willing to be honest again before the next heatwave forces the lesson upon us.